Okay, so here in section 4.6, we want to look at the graphs of the other trigonometric functions, right? The tangent, and the cotangent, and then the secant and the cosecant. So these are all the different learning objectives. Again, please make sure you read them. But the idea is we want to look at those and their variations. These are the examples we'll talk about. Okay, so first of all, what's the graph of y equals tangent of x look like? Hopefully everybody has a feel for this. Right? It almost looks like the cubic function, but then it has a period of pi, so it repeats, right? So between minus pi over 2 and pi over 2, the tangent function looks like this, where minus pi over 2 and pi over 2 are at vertical asymptotes. Okay, and then it repeats itself. So pi over 2 and 3 pi over 2 are vertical asymptotes. So at the half point of each half, so at the quarter point, if you want to think of it that way, we know the tangent is minus 1, right? Tangent of pi over 4, 45 degrees is 1. Tangent of minus 45 degrees or minus pi over 4 is minus 1. So the next thing over here, that means the tangent of 3 pi over 4 is minus 1, and tangent of 5 pi over 4 is 1, and it repeats itself. And that's what you need to be able to draw it. So what do the variations of the tangent look like? Again, we're looking at functions like a times the tangent of bx minus c. Okay, so what we have to do here, let me come over a little bit. It looks like it's out the window. Okay, so what we have to do here is then understand that bx minus c, if I set it equal to minus pi over 2, it gives you the vertical asymptote on the left. And if I set it equal to pi over 2, it gives you the vertical asymptote on the right. Right? When x is minus pi over 2, I have a vertical asymptote. When x is pi over 2, I have a vertical asymptote. That's my tangent function, and then it repeats. So over here, I need bx minus c to be minus pi over 2 and pi over 2, and that tells you my vertical asymptotes. Then at the quarter points, so I'm going to break that up into quarters, and then at the quarter and the 3/4 point of that, the y-coordinate on that side will be a, and the y-coordinate on the left side will be minus a. Of course, if this was a negative value, that means it would flip it, right? It would be reflected about the x-axis, but assuming a is a positive value, the y-coordinate on the right side would be a, and the y-coordinate on the left side would be minus a. If a was a negative value, the minus and minus a would be up here, okay, and flipped. All right, the x-intercept is midway between the asymptotes, right? Just like it's midway between the asymptotes over here. So for example, let's say we want to graph y equals tangent of 2x minus pi over 4. So I have to set 2x minus pi over 4 equal to minus pi over 2, right? And when I do that, I get that my left asymptote is minus pi over 8. Then I set 2x minus pi over 4 equal to pi over 2, and I get my right asymptote is 6 pi over 8. I'm sorry, 3 pi over 8, right? 2x minus pi over 4 equals pi over 2 gives me 3 pi over 8. Break that up into 4. So 1, 2, 3, right? Break it up into 4 intervals here. So the middle value between minus pi over 8 and 3 pi over 8 is pi over 8. Then I get 2 pi over 8 here, which is pi over 4, and 0 here. And then I know its value is negative 1 there and 1 there because the amplitude here, the a value, not really the amplitude for tangent, but the a value here is 1. So that'd be 1 and minus 1. And then it repeats itself from 3 pi over 8. So that's a length of 4 pi over 8 or pi over 2. So it's going to be another length of 4 pi over 8. 3 pi over 8 to 7 pi over 8, and that's where we wanted to graph it, was from minus pi over 8 to 7 pi over 8. Right, here's that algebra where I solved each of these. 2x minus pi over 4 equals minus pi over 2, and 2x minus pi over 4 equals pi over 2. That tells you where the vertical asymptotes are. Okay, let me go ahead and stop this and go over these guys then just a second.